So hello everyone, I'm Chen. I'm assistant professor from the Aalborg University. I'm very excited to be here today to share our latest research of applying the natural language processing in industrial robots. So I think probably most of you already watched this about movie Archive and the TV drama Next, right? It is about this kind of like human equivalent virtual assistant and also the robots. The one on the left develop a relationship with the operator and the other one trying to take over the world. But both of them are able to have the cognitive interaction with a human due to the enhanced NLP capabilities. Well, I think we all fancy all this movie stuff, sci-fi movies, but let's look at today's technology. I believe most of you already familiar with these products, right? It's like Amazon Echo, Google Home, Apple Siri. As they are the most popular NLP and speech recognition driven use case in the market, and people can directly talk to them. For example, you can ask for the weather, book a restaurant. Except for those virtual assistants, many social robots also received higher attention. They provide the multimodal interfaces integrates with different technology. For example, natural language processing, speech, and gesture recognition. And those robots are quite popular in our life. For example, they can provide the guidance in the airport, assistance education, and also for the elderly care. And such social robots can provide a natural, flexible, and user-friendly communication to help the humans in the daily life. But how about our industrial robots, right? So, as we know, the productivity, task completion rate, or the cost are the primary factors when we come to evaluate the performance of the industrial robots. But actually, the overall, the productivity, or you can say the performance, also depends on the human operator. So in Aalborg University, we have been thinking, can we design and develop an intelligent industrial virtual assistant, such like a Google Home or Siri, but more only focus on the industrial manufacturing task, and also can borrow some like humanized features from the social robots. It can provide a scalable, flexible interface to enhance the user experience during the manufacturing task. Therefore, we list our objectives for building such virtual assistants here. The first, our robots, our virtual assistants should focus on the manufacturing domain for the industrial robots. Currently in our AAU lab, we have different type of industrial robots. For example, the MIA robots, mobile industrial robots, and industrial manipulator, Franca robots. The second, we choose the client-server architecture to build our virtual assistant because we need a centralized way to control the robots and also maintain the resource. Furthermore, and the VA, the virtual assistant, should be able to support a natural and flexible conversation for the human-robot interaction. The basic requirements for such communication is the robots should be able to understand the humans, or you can say the operator's intent, and infer the commands or actions requested by the operator. And furthermore, we think this virtual assistant should also support the humanized feature. For example, can tracking the operator's attention during the manufacturing task, and also can enable this kind of like human level conversation to some extent. So here we present the architecture of this virtual assistant. We call it Max. The Max follows the client-server architecture. On the Max server side, we have a spoken language understanding component. It helps to identify the operator's intent, track the state, dialogue state, enables the conversation strategies. I will explain this later. And also maintain the robot service, for example, the robot class and the skills repository. And voice service and robot control components are implemented in the Max client. For the voice service, we use Google speech to text to translate the human voice into the transcript, and Amazon Poly service to generate near human voice as a response from the Max server. And the robot control component is helped to communicate and manipulate the shop floor robots according to the operator's oral command. In our approach, we build the intent identified by fine-tuning the base BERT model. The model takes into account the context of the operator's utterance and pay attention to the meaning of the words in the given context, and it predicts the intent and the slot value. Here's the example of our data set. Currently, we focus on the mobile industrial robot Mia. In total, they have 9 identified intents. For example, updating location. You can ask robots like, can you mark this position in the system? And robots may reply to you, sure, but what do you want me to name it? You need to give a name to this position. Communication between the Max client and the server, we use REST APIs. And all these kind of parameters, for example, the user's utterance will be wrapped into parameters and sent to the Max server. And also in the intent and also the response from the Max server were wrapped into this kind of the JSON string and send it back to the client. Yeah. Furthermore, we think to support a natural and flexible conversation. And Max also be able to monitor the operator's intent, because we observed that the human operators might easily lose their focus when they try to deal with multiple tasks at the same time. So if the operator switch the intent during the mission, and the Max will kindly remind it, I'll show this demo in the later. The other one will be, can Max support a human level conversation? So we studied the human conversation strategy. For example, the lexical semantic here and the general diversion context tracking strategy. And we observe the human-to-human conversation show us the people normally they don't repeat the sentence, even they are giving the same questions multiple times. And besides, the high user engagement is also observed from the active participation in the human-to-human collaboration. For example, human operators may question each other, give each other suggestions, or taking the initiative in a task. So to enable such abilities, 3 strategies are applied to Max. Don't repeat, switch a topic, and initiate activities. So here are the examples. The first demo shows an operator ask robots, Mia robots, to deliver a package to a destination and hand it over to a person.
Hi, Max. I need your help.
Sure. How can I help?
Could you bring this small red box to warehouse and give it to Kate?
Got it. I will deliver the small red box to warehouse and hand it over to Kate.
Hi, Max. What are you doing here?
I am here to deliver the red small box to warehouse and hand it over to Kate.
Thank you. You can keep your mission.
Okay. Have a nice day.
Yeah. So the second demo will be shows how the Max can tracking the operator's attention during the mission. Hi, Max.
What's up?
Max, can you help me to mark this position?
No problem. How would you like me to call this position?
What's your battery level? So you see from here, actually the operator first asked to the Max to mark a position, but then he forgot. He asked another things like check the battery level. No.
I am sorry. Do you still want me to mark this location?
Oh, yes. Yes, I'm sorry. Yes.
Sure, but I need you to give me a name for this place.
Loop 2.
Okay, done.
So the last demo is about embedded conversation strategies. The first one is Max will initiate activities if there are any tasks scheduled. And the second one will be switch the topic. If Max will propose another related to this kind of task, if current one is impossible to continue.
Hello, this is Max. I am ready to work.
Hi, Max. How are you doing?
Not bad. By the way, I found there are 5 tasks on my list. Would you like me to do it now?
Well, no, thank you. Not now.
Sure, call me when you need me then.
But actually, I do need your help.
Well, my battery is lower than 10%.
So from here, you can see the operator asks for help. And the Max, first, he need to checking the system in a state to know currently the battery level is lower. So that means he need to let the operator know what kind of task he can do, what kind of task he cannot do, and give the operators the option or suggestion.
I'm not able to create a map, but I can do some delivery tasks. Would you like that?
That sounds great.
Hello. Hello.
Okay, that's it. And this work is already accepted by this year's Human-Robot Interaction, this conference, as the latest breaking report. Thank you all.